Hello, this is a video for the quick quiz in my IB Year 11 classes about diffraction and interference. So the first question is something to do with this person around the corner. This person can hear the sound but not seeing it, not seeing the car, I mean. So that explains that sound wave can diffract much more around the corner while the light wave can't. And that's the only possible answer. Number 2 is something to do with the lamp, why we can't see the interference pattern. So obviously you shouldn't be choosing C or D because intensity of the light shouldn't be affecting the interference pattern. So you can imagine if one is dimmer, one is brighter, you should still be able to see the interference pattern. While D doesn't really make sense as well, because we can still see it, and no matter it is a point source or not, I mean practically. So it's more about think about A or B here. I guess if you're getting it wrong, probably you chose A. And if you think about the frequency, you may be thinking, hey, interference needs to have the same frequency or same wavelength. So let me show you over here where you have let's say 2-point source, and just like what we learned previously, you can always find certain point that you can have, say here, constructive interference, while the point where you have not only one single stroke like this point. If I try to make it larger, over here you have destructive interference and constructive here, constructive here, constructive here, and destructive here, right? And that's very normal because that's what we learned. But if you try to think about the case where let's say I change the frequency here, make it so huge, in fact you can still find there should be certain places, let's say here is also peak meeting another peak. So here you still have constructive interference, while at this point here you have the peak meeting the trough, because for this shorter wavelength this is a peak, right? For the longer wavelength, this one is between these two, so this is the trough of the bigger, longer wavelength, that one. So this must be a destructive interference. So again, this is constructive, this is constructive, this is destructive. So if these two sources are coherent, that means they always give out the same wavelength all the time, then they should have the interference pattern, although it may not be symmetrical as how we usually see, but it's still interference. And back to the answer here, B here, the problem with if the phase differences keep changing, the thing is, you may say, hey, so in this case, why can't we just still have the interference pattern but changing? You know what I'm talking about? The interference pattern can actually still be obtained, because the idea of interference itself is simply superposition. And superposition in itself is simply just adding the amplitude of different waves, two waves, for example, together. Let's say if you have amplitude, displacement 1 meter positive and the other one positive 3 meter, you just add them together, become 4 meter. If you have one which is negative 2, which more like a trough, and the other one is positive 1 meter, you make negative 1 meter as a displacement in total for superposition. So back to here, the problem is having the phase difference always changing is, yes, if you take a photo, you maybe can see, and that is to say, if you freeze the time, you may be able to see a certain interference pattern at that instant. But the thing is, think about the frequency of a light, of a lamp, is usually very high, that you can't really actually catch a moment. So the problem is, if the interference keep changing, so it's basically like the wave keep wobbling around at a very high rate. So like this monitor is actually flashing with certain frame per second as well. you can't see it because our eyes simply can't see such quick change. So if you try to argue that, hey, there is still interference pattern, but the thing is we can't actually see the change of this interference pattern so quickly. So at the end, what we see is just random pattern keep changing all the time. So legitimately, I don't think we can call it interference pattern. But let's say in this case, it's still an interference pattern and it's always the same place having constructive and destructive interference. So that's why for interference pattern, we always would want to have the coherent sources. When we say coherence, doesn't mean they must be having zero phase difference. As long as we have the phase difference to be constant, that will be good enough. For example, if you have pi, that means 180 degrees change, then it's still fine. It's more about the equation that you learn about constructive and destructive interference. That means n lambda and n plus 1 over 2, n lambda plus 1 over 2 lambda would not be whole directly, but you can still deduce it. But the thing is, at least this is a pattern, is always like this, is always the same, where you won't be where you can actually capture and always see for example the constructive interference, destructive interference, and of course the anti-nodal line and nodal line as well. So moving on to number 3 is the same thing, constant phase difference. Number 4, this is something to do with, if you read the question, you know normally double slit you have bright which is constructive, dark fringe, that means no light at all, and that is also destructive interference. And now what it said is if one of the source, one slit, reduce the amplitude, that means let's say the amplitude of this is, it was 10 and 10 originally, but now what you do is you have 10 and 5, for example, or maybe let's say 10 and 2 to make it easier. So when you say amplitude 10 and 2, that actually means it fluctuates from positive 10 to negative 10, right? You know that's how the wave will move. And this also positive 2 and negative 2. So in this case, originally the constructive interference will have 10 and 10, which is 20. And now you only have 12 because 10 plus 2. And while for the original dark fringe, the dark fringe actually it was having positive 10 plus the negative 10, which makes it 0. But now you may have, for example, positive 10 and negative 2, which makes 8 only. Or you may have negative 10 and positive 2 to make it as 8 instead. So you will find the dark fringe can never be, the destructive interference can never be totally dark in this situation if the amplitude are not exactly the same. So it will be brighter, must be more than 0. And while the bright fringe, of course, it cannot be 20. It cannot be as much as before, for sure. The next question is also quite interesting. What you do is it asks you which one will have a path difference of 1.5 lambda. And obviously these are the sources, and you know in the middle the path difference, since it is basically isosceles triangle, so you know this path difference must be 0 along this line. And this is the next one here is a nodal line where you find destructive interference along the way, and surely you know the path difference must be 0.5 lambda, and so on and so forth. So this one is 1 lambda, and the next one must be 1.5 lambda. So the only answer is number 3. Question 6, again, the coherence issue. It has to be coherent. Number 7. Among these answers, I don't really find this is a really good question, but from all these options, the only thing that I think we can choose is D, because if this is getting so small, the reflection, the reflected rate will be less, and while the diffraction will be more. So if you consider the energy, in terms of energy, whenever you have the diffraction, like whenever you pass through the slit, this is the energy that can be transmitted after the obstacle. And that is to say, the more you diffract, the less you reflect, because conservation of energy. So in this case, if you're getting smaller, more diffraction, reflection should also be less as well. And I guess this is very intuitive. Number 8, again, the idea of Yan's double slit experiment using a single slit sphere is to make it coherent at the first place. Number 9, I guess you just need to pay attention to the wavelength, which is 2 meters, and they are also in phase. And these are the diagrams. So here, I would like to draw a half cycle. Here you've got 1.5 cycle. So anyway, you can see that they meet at P with the same phase. So in this case, it must be constructive interference. So 2A will be the answer, since each of them is 1A. 10 will be quite easy, just simply add what you learn in IGCSE. So this, of course, will be the same wavelength and just extend a little bit, like this. 11, again, constant phase change. And 12 is similar to 10, so I'm not going to explain it. 13 is also quite interesting, although it should be quite easy. This is double slit, this is the central maximum. So you know, again, central maximum, the path difference is 0. And the question set at P, the path difference is 4 lambda. I know it's a pretty easy question, but I try to do it carefully. So what I did is, the first maximum, not first maximum, apart from the central maximum, the first order of the maximum will be 1 lambda, and the second one will be 2 lambda, and so on and so forth. So for the 4 lambda, that one will actually be the 4th order. But when you try to count how many bright spots are here, there should be 5, because you include the central maximum as well. And the question is asking you at P, of course, it must be bright, since apparently this is constructive interference. And also counting up the dark fringes between 5 bright spots, and definitely it has to be 4 between them. If you feel like so, you can try to count as well between these things. So 1, 2, 3, 4. So the answer is B. 14, diffraction. I guess you have, of course, you have seen water wave and sound wave, and for light wave, you can also see it. But the thing is, it's hard to observe because the wavelength is much shorter, but it can still be seen. And of course, you can see it in the interference pattern in the double slit and single slit experiment. Lastly, you have got 2 different waves, and what you can see is it asks you about the amplitude. So when you say amplitude, how it's defined is different from the so-called displacement. Amplitude is basically meaning the maximum displacement you can have. So if you are talking about the interference of P and Q, so simply just look at the possible highest value you can get from these 2 waves. So I guess you may want to look at this point, which is 1. 1 plus 0 is 1. Or you can try to find another point that is higher. So I would like to put this point, which is about 0.7 for each of them. So altogether will be 1.4. And if you look at the answer, and that could be chosen here. And while for D, if possible, but I mean 2 millimeter, but from the graph itself, there's no way you can find 2 millimeter, because it has to be peak and peak, since the scale is 1 up to 1 here. So the only option you can choose is just C. And lastly, this one is again the same idea. You must have the constant phase difference, and at the same time, definitely you have to meet at the same point. Otherwise, it just doesn't make sense. And while for a similar amplitude is again is not really necessary. Although the thing is, if you do not have similar amplitude, like the previous question in Where is it? In the previous question here, you will not have the dark fringe. So that means you will not have a complete, I don't think this is a proper word, but completely destructive interference. That means the least amplitude you have is not 0, but that is still destructive interference. So that will only be the issue if you don't have the same amplitude, but you should still see the interference pattern. Okay, so if you still have questions, you can leave a comment and ask me.